how to effectively use generative AI to facilitate learning for this MIPS code assignment. And the game we chose is Draw the Joker. It's simplified. Team members are Wei Tian and Huang Yang. Now I'm the one who is explaining the content. We both contributed to the slides and the content of the slides. So assignment requirements. First of all, we are supposed to choose one poker game. As I told you before, we chose Draw the Joker. Then I'll be describing the rules. I will show you the C code and the translation to MIPS, and then how AI helped us, and upload the YouTube video as well as the slides. So the game rules are basically like this: only one player for simplification and for generalization. They input 5 integers, and each integer represent one card. For example, here's the Joker, 13 is the King, 12 is the Queen, 11 is the Jack, and 1 till 10, basically the numbers. The Joker acts as wild card to complete sets. For example, if you have 3 of a kind with a Joker, that is considered 4 of a kind. And the scoring is also shown on the screen. Example hands. For example, if you got 2-7, a pair, and 2 Jokers, it's the same as 4 of a kind, and the score is 4. Then we can see another input where you don't have pairs, score 0, and then same as the first one was, but only with 1 Joker. 4 of a kind. And the program flow. So basically, first the parsing, the input. When we read the 5 cards from the input, then we count the Jokers so that we later on can find the largest group plus the Jokers, and this way we can find the final score for the player. Then, of course, print the result. This is a full C code. I think it was pretty easy. Actually, it was mainly developed by us, which I think is pretty simple to understand. Here on, I'll be explaining both the MIPS code and the C code. First, it's parsing the data and the input. The left side of the screen is for the C code, and the right side of the screen is for the MIPS code. We can see that we define an array of 5 elements, which are integers. We do a for loop, and we scan the 5 inputs, which are integers. And also, we are doing that in the MIPS code. We see that we use a line because this way the bytes can be aligned and following each other, so it's more organized, and we don't have any register or byte errors. This part, we just use branch equals in order to do the sub for the for loop, and basically teach you our stopping condition because we go from 0 to till 5 in the loop. We are just scanning here. This is a little bit more complex in terms of maps. It's quite long. In C, it's pretty simple. This array is like basically the position. 13 is the number of cards that you have received. King, for example, from the king card. And we are basically doing the same here in maps. We are clearing the loop. Then after the frequency is done, we go to this part of the function. Then we do the count loop for jokers and for the frequency values as well. Then this function, if it is joker, we jump till there. And the next I, it's basically for this part, for the incrementation of the iterator, which is I. We have part 3, find the maximum frequency. This part is quite easy as well because we are going over all the frequency elements and we're just finding the maximum value of the array. And that's pretty straightforward. And the same thing here, no update. We can sum one to the iterator. After max is done, we go to max done function. And we use the variable boosted, which is a max count, the number of elements of frequency, which got the highest value, and then we sum up with joker. What happens if, for example, we have 4 of a kind and then we have 1 joker? The boosted score will be 5, but then we have our own if condition that if boosted is more or equal to 4, it's still 4. And so it's pretty much the same. We still get a score of 4 if we have 4 of a kind plus a joker. These boosted variables pretty important so that we can align jokers with the actual frequency score, the maximum score that we got. And it is also pretty straightforward. Branch greater equal to branch equal to, we use the ifs just like here. For the print score, we jump to print score, and that part is also pretty straightforward. The test cases, I'd like to test this in more so that you can see that it actually works. And let's input the following: 77, 0, 0, 2 jokers, and then a random number. We get a score of 4, which is correct because we have a pair and then two jokers equals 4 of a kind, and the score is 4. Then we run again. Two, then a joker, and then a 9. We get again a 4 score. Perfect. And then we use 10, 4, 3, so 6. No pairs, so we get a score of 0. And then 9, 9, 5, 0, 11, and 3 because we got a pair plus a joker. Perfect. And how AI help us? It explained the poker rules to me, the simplification rules, also improvements for our C program, and then it mainly helped us translate each part of the C code, which was pretty simple to MIPS, in which we had trouble developing. We didn't use any safe registers and avoid using the stack pointer because we still think that's kind of confusing. It's just moving the stack pointer and below so that we can allocate the save registers and then return the save registers, but it's still simpler if you just use temporary registers for everything. And it also help us debug and suggest how to structure the slides and slide content and the video. And our conclusion is that we implemented successfully the version of Throw the Joker, that we developed the C code plus the MIPS code, also explain everything through this video, all the slide content, also provided the PPT file link and the YouTube video link. Also, AI helped us a lot in learning process, learning faster, avoid errors, and present results clear. So it's basically that, and thank you for watching.